there's things like ground source and air source heat pumps. And what we're going to talk about today is heating, and in particular the ambient heat that's available, which heat pumps can do, rather than deal with biomass boiler or solar. Now, this slide, I think, is also fairly self-evident, but I just want to go through it slowly. The reason for renewable energy sources is they have little or no environmental impact. Solar thermal and solar electric peak during the summer, but what we really want to do is to heat our house in the winter. Wind energy peaks in the winter. It's very variable and is generally not strong in urban areas. Most of the wind turbines are now going out at sea. So there are all sorts of issues with transmission and distribution. The advantages of heat pumps, just so that to make certain that we're talking about the same sort of thing, is they concentrate the ambient heat present in air, ground, or water at any time of the year. And they can use solar electricity if it's available to provide the electricity input. So they concentrate the heat, they do not generate it. Any questions with this slide? No? Then we'll move on to the next one. Now, this is the first of the important slides. They're more efficient. Heat pumps are more efficient than gas boilers because they, as we mentioned before,
come and watch this.
they concentrate the ambient.
You're not to eat all my feasts. Have a Slero.
And
rocket. You wanted the fruity rocket one.
Sorry, somebody needs to mute themselves because you're. It's not helping the others to hear what I'm saying. Yeah, and the sources. The other thing about the heat is that certainly underlying Reading is a chalk aquifer. So if you're drawing heat from the ground, then the ambient heat gets renewed. Geothermal heat gets renewed during the summer due to flow of groundwater. The real reason for heat pumps is that they can produce up to 4, sometimes more than 4 heat output for each unit of electricity consumed, and they can provide both space and water heating, which is the greatest use of energy in the home. Technology is very old. The first heat pump was designed and constructed almost 200 years ago. And heat pumps are already installed as of 2020 in 10% of the EU housing stock and being installed at the rate of something like 2 million heat pumps a year. So you already have the advantage of cost reduction associated with large numbers of installations. The fact that there are only a small number of those 2 million heat pumps are installed in the UK each year is just because we're starting now, whereas countries in Scandinavia started 40, 50 years ago. Are there any queries on this one slide? No? Right, then we'll move on to the next one. Now we come to the key steps before you install a heat pump. And the key step is to reduce the conversion costs. So step number 1 is to reuse existing radiators. And what is very important is to understand the first bullet. Radiators for gas boilers are currently sized for central heating water temperatures of 70 degrees C. So a typical gas boiler will generally operate at 70 C. So the radiators are sized for a water temperature of this amount. They're always oversized by some amount because no installer wants to be called back because this is installed too small radiator. But they're generally sized for 70 C. But, and this is the second important point about heat pumps, They operate at central heating water temperatures no greater than 45 to 50 C, and possibly a bit less. So the question is, how can one reuse radiators at lower water temperatures? And it is possible to do that if you reduce the heat loss of the dwelling. So you would need fewer radiators, and then, which is fairly self-evident, but which is less evident, and something that we will deal with in the next slide, is it's important to limit the corrosion in the radiators in order to increase or restore their efficiency. And I'll describe in the next slide how this can be done. Any queries here? Remember that the cost of replacing the radiators in a typical UK semi is about £3,000. So if you can reuse and restore the existing radiators, you can save yourself not only £3,000, but you also can save yourself all the hassle and other things involved with having to replace the radiators. And the way you can restore radiator efficiency is to limit corrosion between the central heating water, the pipework, and the radiator. And there are products on the market. I can recommend this one, manufactured by a firm called Vexo. And the reason why I recommend it is that I first installed this in my radiators 12 years ago. And as a result of that, I've been able to operate my radiators at temperatures of 40 to 45 C rather than at 70 degrees C, simply because I've restored the radiator efficiency. So I've been able to reduce the central heating water, lengthen the life of the heating system. Before I installed, can somebody mute themselves, please? Before I installed, can somebody mute themselves, please?
Emmy, is there any possibility that you can mute your microphone? I think it's coming from your.
Not coming from my microphone.
No, I said Emmy.
Oh, it's Amy, is it?
Yeah.
I wonder if it's possible to mute. Sorry about this.
Hi.
Hello.
Rayner, can you just do a mute all? You should be able to mute.
This is what I'm looking for.
Right. I'd already written to Emmy asking to have her to mic
Pause recording reactions, meeting info, and I'm looking to see how I can mute it. Remote control.
Yes, please do.
Sorry, we've never had this problem. Mute. Wait a sec. Who's that for mute? Yeah. Microphone, same as speakers. But select a speaker.
How this will be helpful, Amy? Not at all related to.
Who knows that? She told it will be useful. That's it.
Oh.
Screenshot, right?
Heating pumps, sir.
We seem to. Yeah, well, we seem to have. Sorry. Lengthen the life of the heating system if you can limit corrosion. Now, before I added this inhibitor, I had to replace the heat exchanger in my gas boiler after 2 years. Now, having added this, I've now got 12 years out of my replacement heat exchanger, and it's still going strong. So therefore, I can thoroughly recommend it. It'll lengthen the life of the heating system, even if you've got a gas boiler, and it's even more important if you've got a heat pump. The important thing is there's a minimum level for each of these inhibitors, these scalars, And the important thing is to check the minimum level when your gas boiler or heat pump is serviced. Are there any queries before we go on to step number 2? If so, please fill in the chat box. Right, don't seem to be any queries. But this is adding the inhibitor descaler is best done by when you have your boiler service. The cost of this inhibitor descaler is about £10, £15. So the cost is negligible. It'll take about 5 minutes to add the chemicals via the top-up loop. So I can thoroughly recommend it. And you can buy this at any heating, plumbing shop. It's in commercial production. Right, now step number 2 perhaps is a bit easier to understand. And Mehdi, would you like to explain why it's important to reduce the heat loss?
Thank you, Rayner. Yes, there are different schools of thought in terms of decarbonization of the heating systems. One that both Rayner and myself belongs to, we believe strongly that we have to reduce the heat losses from the buildings first and reduce the heat demand first, then apply the new and decarbonized technology like heat pump system. The rationale behind that is, first, when we think about the characteristics of the heat pump systems, heat pumps works, as Rayner mentioned, heat pumps work at very lower temperature compared to the gas boiler that are traditionally installed in the UK building stock. When we reduce the temperature of the central heating system from, for example, typical 70 degree to something around 50 degrees C, it means that if we don't reduce the energy demand of the building, probably we need to increase the area of heat transfer, which has an implication on increasing the surface area of the radiators, changing the circulation pumps, and so on, which all of them together are very, very expensive. If we reduce the heat loss from the building, we can potentially use the existing system, replacement of the boiler with the air source, with the heat pump technology, doesn't matter, air source or water source, and use and replace the system with the heat pump technology. That's the main rationale behind the need for reducing the heat loss before sizing the heat pump systems. Another reason behind this is considering the space. There has been number of large scale experiments in different parts of the UK, from Wales to Scotland, that they explore barriers for uptake of the heat pump technology. One of the biggest barrier of the heat pump technology from the perspective of the homeowners was the space for alternative for the gas boiler. Normally gas boilers are either located in the kitchen or the utility room or in setting in the garage. When we stick to the existing heat loss of the building, the size of the heat pump would be big, and there would be a issue of a space when we are replacing the technology. These are the two main reasons behind the strong recommendation to first reduce the heat loss from the building, then attempt to size and replace the technology of the gas boiler to the heat pump technology.
Let's stop there and see whether there's any discussion or any comments that people want to make. This is very important. Both the restoring the radiator efficiency and reducing the heat loss are essential if you're going to reduce the installation or conversion cost from gas boilers to heat pumps. It isn't there, neither of them are options, neither of them are that expensive compared with the benefits that it brings. Any comments or concern? Right, then we'll go down to the next slide. Mehdi, if you can talk us through.
Yeah, of course. I think insulation to reduce the heat losses. One of the cost-effective approaches to reduce the heat loss from buildings is adding the insulation. The first, most straightforward part of the building, or the bottleneck for many of the building, especially the existing building stock or building stock, is making sure that we have enough insulation in the loft. The way to check, we can simply, if we are competent to do so, we simply can go to the loft, measure the thickness of the loft, insulation in the loft, if there is at all any. And if it's less than 30 centimeters or at least 25 centimeters, it would be a very good idea to increase the thickness of the loft insulation, or replace the compressed old insulation if it's very much compressed. Just I would like to emphasize that when we have a loft insulation, if they are compressed over the time by, if someone put some boxes as usual in the loft or so on, the heat the thermal resistance of the insulation would be reduced significantly when they are compressed. The next step to reduce the heat loss from buildings is to think about increasing the insulation on the external walls. Increasing the insulation of the external walls is slightly different from, more challenging than the increasing the insulation in the loft. For the loft, it can be done as a DIY if we are competent to do so, as long as we are not putting our feet, or if we make sure that we put our feet on the top of the joist, not the plasterboard. But for the external wall, it's more challenging. If we are lucky to live in a building post 1945, it's most likely the building is the external wall is a cavity wall, and if there is no insulation in the cavity, injection of the insulation in the cavity is a reasonably straightforward solution. But if it's a solid wall, pre-1945 building stock, we need to think about insulation, either external, on the external leaf, or internal side of the wall. Putting the insulation on the external solid wall is reasonably expensive, because we have to think about the moisture transfer. We have to think about the cladding on top of the insulation, and the same, there would be some challenges putting the insulation in the internal side of the solid wall for pre-1945 building stock, as it reduced significantly the usable floor area of the room and building. Another approach that we can think about to increase the heat losses from buildings is, if for building, if the windows are single glazed, thinking about double glazing or triple glazing the window. Again, it's very expensive, major refurbishment for the building to completely change the windows, but there are other alternatives, more cost-effective alternatives for the single glaze windows, like using polycarbonate layer on top of the glass to increase the thermal resistance of the glazing of the window. These are the measures that we can take to we can consider to reduce the energy consumption associated with the operation of the building.
Any comments or queries there? I noticed there's some things in the chat box. I don't know, John Sharp. Do you think
Okay, there is a very good question. Do we have any advice as to how to minimize the heat escape from the chimney that are in use in winter? John Sharp,
yes,
you
please.
should be the best person to answer that question.
Okay, you can't really minimize the heat escape from chimneys that are in use in winter. Because otherwise you're going to have a major problem with the smoke in your house. If you want to just minimize the heat escape, not from chimneys that are in use, then there are various solutions. You can get plastic balloons that will go up inside your chimney. I haven't used them for a couple of reasons. One is that I'm not sure how long they last, and secondly, I'm not sure how well they work. But what I have used is a thing called a chimney sheep that I've put in all 4 chimneys in my house. They come in various sizes. For my main lounge, it was a large size, which wasn't a standard size, but you can get you can get non-standard sizes measured, made to measure, and I put it in about 2 years ago, and it cost me £65 for the largest non-standard one, so it's not incredibly expensive. You need to obviously be able to get up into the, look up into the chimney, which can be quite an interesting thing if you've never done it before. You probably want to clean it a little bit, measure the size, and then you push the chimney sheep, which is made to measure or should fit fairly well. It's basically a layer of sheep's wool in a container, really, and just push it into place. It has a bit that hangs down to remind you that it's there, so you don't forget it's there and decide to light a fire. Which I actually tuck mine out of the way because I'm not planning to use my fires. And it doesn't completely prevent airflow. So you still get, because it's sheep's wool, you still get some passage of air going through it. So you wouldn't get the problem that you would get potentially if it was completely sealed up, and then you can get issues with condensation inside your chimneys. So yes, I've had them in for 2 years. They seem to make a very significant difference. Didn't cost very much, and I haven't really had any downsides so far.
Thanks, John. There's some other queries in the chat box. Would you like to mention them so we can discuss them? John already. You're muted, John.
Yeah, sorry, what do you want me to discuss, sorry?
There are various things in the chat box. So do you think you could read some of them?
Oh,
Yeah,
out?
I'm reading, Rayner.
Oh,
Do we
right,
have
maybe.
any advice as to how minimize heat escape from the chimney? We addressed that. My understanding is that for Windows, the newest standard is for a U value of 0.8, which means triple glazed.
Hang on a sec, just let's stick to that. I mean, yeah, sure. If you want very low loss windows, then the answer is triple glazed is the obvious way to go. And it's standard on the continental Europe. But you must remember that it's not cheap, and therefore what you want to do is to balance the heat loss versus the cost and size of the heat pump. So you don't need triple glaze. In new homes, you might well get it, but I mean, what we're suggesting on this slide is even using secondary glazing will significantly reduce the heat loss. And if you can afford it, well, double glazing is better, triple glazing is even better. Any other chats at all that we need?
Yes, I'm going to read, but on top of answer from Rayner, the suggestion for the double glazing and polycarbonate layer mainly was for the existing building stock. In the new buildings, you know, the contractors are have to comply with the building regulation, and the new building will come with the windows that meet the bare minimum requirement of the Part L building regulation. There is another question, or we have one of those. They are great. Good to hear that they are held in high esteem. Okay, great. How thick does the wall insulation need to be, and is there any impact on airflow in the building, underfloor, etc.? The thickness of the external wall depends on the thermal characteristics of the I can imagine that you are talking about the solid walls. Building stock pre-1945 depends on the thermal characteristics of that wall, and first, and second, based on the thermal resistance of the insulation that you are going to use, the density of the insulation layer, and the material used, the thickness should be defined. I cannot specifically mention any thickness here because it depends on these two factors. First, thermal characteristics of the wall, and second, thermal resistance of the material that you use for the insulation of the external wall. And on top of that, the amount of reduction in heat loss that you have in mind. These three factors define what thickness for external insulation for solid wall should be used.
We can just add that typical values are somewhere between 50 and 100 millimeters to give a quick answer to the question for the reason that maybe. Any other in the chat box?
Another one, re-chimney. We use some loft insulation in the back, stuffed up to the chimney until we wanted to use it. You know, that's another solution. Okay.
Yes.
Yeah.
Yes.
Some form of external shuttering of the window can presumably help with unwanted solar gain in summer, but can it also help with the heat loss in winter when it's dark for up to 16 hours a day? One thing that I can say, any kind of window shutter, I can imagine that can help in terms of providing a barrier for heat loss, but the extent of this might not be significant. That's my my response to this point.
It can help, but a lot depends on the shutter and how tightly it's fitted. I think we'll move on to the next slide because this is still an important thing. Mehdi, if you can talk us through this one.
Yeah. In terms of heat pump technology, if we can suggest something here for a typical domestic building, by typical, we are not referring to a building with 300 square meter internal area. For a typical semi-detached or reasonably sized detached house, if we can reduce the heat loss of the building up to maximum 5 kilowatts, we would be able to feed a good size heat pump technology that can work with the temperature, outdoor temperature of -1 during the winter and produce something around 5 to 6 kilowatt heat when needed. One of the important things that we have to always have in mind, if we are using the combi boiler, by combi boiler, if you are not familiar with that term, the combi boiler is a boiler that produces heat for central heating for radiator and instantaneous heat for domestic hot water to be used in shower and wash hand basin and so on. If we are replacing a combi boiler with heat pump technology. Heat pump technology, we have to bear in mind that heat pump is not capable of domestic size heat pump. I'm not saying heat pump is not capable of, but domestic size, domestic design heat pumps are not capable of providing instantaneous hot water. For that reason, we have to bear in mind when we are replacing combi boiler with the heat pump technology for the domestic hot water, we need to think about the storage, hot water storage tank that can be linked to the heat pump, but heat pump would not be able to provide instantaneous hot water. But when the heating demand is low, they switch to produce the heat and use the heat for heating the hot water tank for the domestic hot water, for providing the domestic hot water. Rayner, is there anything else you would like to add to this slide?
No, the question is any queries or comments? It's important that you understand the differences between gas boilers and heat pumps, simply because decisions that you make now or between now and the time when gas boilers will no longer be available, even for existing homes, it's worth bearing in mind the comments that Mehdi has now made, because it will save you money in the long run when you will all have to convert to heat pump. So let's move on. Mehdi, will you talk us through air source heat
Of
pumps?
course.
Okay.
If I'm allowed to, may I ask the audience if anyone doesn't have a heat pump system at home, can you come to your microphone if you're happy to come? Is there anyone that doesn't have heat pump at home?
Question is more whether anybody has a heat pump, not whether they don't have one.
Okay.
There's one person called Ross who's had a ground source heat pump for 15 years and is
Okay.
still working fine. So that's the only person I know who has a heat pump at the moment.
Is there anyone from the audience comfortable to come to the microphone?
I can tell you a little bit about my heat pump if you like.
Okay, I will come back to you for your heat pump, but now I'm a bit interested to see, to talk with one of the participants that doesn't have a heat pump. Is there anyone keen to come to the microphone?
They all seem to be in listening mode.
Okay, okay, that's fine. That's fine. What is the heat pump
Stephen
system?
Mandel has written that he doesn't mind.
Okay.
Yes, okay, hello.
Hello, Stefan. How are you?
I'm okay.
Thank you very much for coming up. May I ask whether you have a heat pump at home?
No, we don't. But what we have is a pellet boiler for us,
Okay.
both central heating and hot water.
Yeah, that's great. Do you have fridge at home?
Yes.
Okay. The point here that I wanted to make is heat pump is nothing at all different from the fridge.
Yes, I'm aware of that.
That's the exact cycle, the exact technology. Nothing significantly different from a fridge or fridge freezer or a freezer. That's exactly the same technology. It has a compressor, it has an evaporator inside that cool the inside, it has a condenser at outside that transfer the heat outside, and there is a little things called expansion valve. These are the four main components of all heat pumps, including fridge, freezer, and the heat pump that nowadays people talking about as a replacement for the gas boiler. Stefan, thank you very much for coming up. Okay, what is the heat pump technology? In nutshell, if I want to introduce the heat pump technology, heat pump is a technology that provides us with the opportunity to extract heat from low temperature heat source to high temperature heat sinks, quite the opposite of the nature. In nature, heat transfer from high temperature heat source to low temperature heat sink. Heat pump extracts heat from low temperature heat source and reject it to high temperature heat sinks. There are different type of heat pump technology that can be used in buildings and for providing the required level of heating and cooling. I'm not going to talk about all different types, but focus on two main types that typically generally can use in building stock: air source and ground source. We have water source, different type of water source heat pump, and so on, that we are not going to talk about them. Air source heat pumps are the technology that take the heat from the outside air, reject that heat to the indoor environment. Indoor environment like inside the room. Even without radiator, we can just use heat pump, extract heat from outside and reject it to the inside air. We need, in each room, we need to have one of that indoor unit. That's called air-to-air heat pump. Or we can use air source heat pump to extract heat from cold outside and reject it to the central heating system that circulate that heat to the radiators. That's called, again, air source heat pump. The air source heat pumps are relatively easy to install. There is one external unit, or one or number of external units like the one that showed in this slide. We can install it on the ground or on the wall. Some has some hesitation on the appearance of the building. They don't like it to be exposed, to be seen. Some put the external unit in the garden, hide it somewhere with a certain clearance from any barrier or so for heat transfer. But one of the negative of the outdoor unit of air source heat pump is they are producing noise. They are not like a jet engine, but they can produce up to 40 to 45 decibel of noise. Generally speaking, for the domestic buildings, those, how many I saw so far, something around 50, 60, 70 heat pump installation. I haven't noticed very loud noise, but it's noticeable. They are producing some noise. Just wonder, is there any question on this slide?
I think we should take the second slide and then take that.
Installation of the air source heat pumps compared to the ground source heat pump that I will go to talk about, that is in terms of installation costs, it costs less for us if we choose to use air source heat pumps. However, the thermal efficiency of the air source heat pumps are lower than the ground source heat pumps, and consequently the running cost for air source heat pumps are slightly higher than the ground source heat pump. What is the rationale behind this? Let's get back to the fundamentals of heat pump. Heat pumps are the technology that extract heat from low temperature heat source and reject it to high temperature heat sink. Air source extract heat from air. What is the temperature of the air during the winter? Let's say 0. What is the temperature of the ground during the winter? Undisturbed ground. The temperature of the undisturbed ground is something around, let's say, something between 11 to 12, 13 in that range, depends on the characteristics of the ground. That means if we use air source heat pump should use more energy to extract heat from a 0-degree air compared to ground source heat pump that needs to use less energy compared to air source to extract heat from the ground that is something around 11 degrees C. For that reason, ground source heat pumps are running thermally more efficient and they're with lower running cost.
Good. I think at this stage we should stop and ask if there are any questions about air source before Mehdi talks about ground source. There are
We've got a
in the chat
couple of
box.
questions.
Yes,
We've got
please.
2 questions that have come in. First of all, from Stephen Mandel, what are the relative costs?
We'll come to costs in a minute, and also grants. So we want to get the technical issues out the way first.
And someone has also said, can you give an example of what the 40 dB noise is similar to?
Well, I think the simple answer to that is if you're sitting in your garden and you can hear the noise next door, so that you can't hear your wife talking to you, that's 40 dBA. I mean, it's rather not an ideal sort of thing, but if it's much above background, so you have to raise your voice in order to be heard, then the answer is it's noisy. Certainly here in Yateley, it's already become a problem where 1 or 2 people have come across this 42 dBA barrier in terms of noise, because the neighbors can complain and then you have a problem. So it's worth checking or get the installer to check before you decide to install an air source heat pump. But a lot depends on your house. If you're part of a terraced house, clearly the distance between you and your neighbor is small. If you live in a detached house, probably much less of an issue. So therefore it's got to do with just how far you are from the neighboring house, and also as well which wall you put it on.
I think it can depend somewhat on the manufacturers to some extent, because of last winter I was out walking in the Chilterns on that day when it was extremely cold, on the days it really was -5. And I came across a house and they had 2 air source heat pumps on the side of their house right beside the road. So I was stood right beside them and you could barely hear them. They were so quiet, running at -5. So either they had a super efficient house and they were hardly having to do any work, or they were very, very, very quiet heat pumps.
Well, I think it is potentially an issue, and of course it's worth checking with the neighbor about your intention, because the worst thing to do is to get them to complain afterwards to the council, and the council asks you to remove it. So it is a potential issue. Any others before we go on to ground source?
Can I
Right.
just briefly
Yes.
mention that I used to work at Woodley Library, and they have had air source pumps put in, and they are incredibly noisy. In fact, they've had problems because they're facing somebody that it's causing an issue, but it is a big building they're trying to heat. So, and I think there might be planning problems for some people as well. I think some planning issues about whether you can fit them as well.
Yes.
Sorry to be negative. I don't want to be negative, but
no, it is an issue which has to be faced as more and more heat pumps are installed. So it is an issue and it won't go away. It may be that some heat pumps are quieter than others. But again, I come back to the fact it depends on your location, the size of your house, and something. Let's move on to ground source then. Ready? If you can talk us through the next 2 slides.
Yes, of course. we were talking about the ground source, the same as we were talking about the air source heat pump, the same as air source heat pump, the same technology can be used for ground source heat pump system. As I mentioned, they extract heat from the ground instead of air. And for getting that heat from the ground, there are a number of technology, two of them laying down some horizontal ground loop or vertical borehole and vertical heat exchanger on the ground to extract heat from the ground. For the boreholes, generally speaking, boreholes are a hole in the ground with the depth of typically something around 100 meters, typically. In that hole, we put a heat exchanger, which is a kind of for making some sense about that heat exchanger is 2 or 3 round of pipe that goes down, and the thermal fluid inside that pipe would transfer heat with the ground and extract heat from the ground and transfer it to the indoor unit of ground source heat pump technology. For the horizontal ground loop, we can bury some pipe on the ground with the depth of something around, depends on the design, something around between 1.5 to 2 meters in that range on the ground, that there is no need to make a big hole of 100 meter typically. But the reason that I'm saying the borehole of 100 meter is typical because those contractors that make the borehole and install the ground heat exchanger, they can do one borehole in one day and 100 meter borehole in one day. We have to be very careful for the cost and environmental impact. We need to get the permission from authorities for making the ground heat exchanger, ground vertical boreholes. I'm sure Rayner will give us further insight on that. In terms, after installation of the ground source heat pumps, the thermal efficiency of the system would be higher than the air source heat pump, and consequently the running cost would be lower. One point that I just wanted to highlight is it's not applied to the domestic buildings, but there are many commercial buildings that they in London, I'm aware of 3 of them, they put the borehole on the ground and build the building on top of the borehole. That's structurally can be okay, but let's assume it happened for 2 of those 3 that there is a need for maintenance of those ground heat exchanger, and at the end they decided to put the cap on them and find another solution. Always we need to think about the means of maintenance for those ground heat exchanger. Otherwise in long term we have to forget about those ground heat exchangers without maintenance. Is there any specific question about the ground source heat pump on this slide?
I think we'll take the next slide and then we'll do questions, and we'll ask Ross to talk about.
Yeah, this is the picture from a typical heat pump system that is able to provide 6 kilowatt of heat and also very reasonably fit into the typical airing cupboard. On top of the heat pump system, there is I can imagine something around 100-120 liter hot water cylinder that's connected to the heat pump to provide not instantaneous heat, but the domestic hot water that needs for bath and wash hand basin and shower and so on. This is just a typical example of if we reduce the heating demand of the building to something around 5 to 6 kilowatt, we can fit a heat pump technology with the hot water storage cylinder that suitable for a typical domestic building in an airing cupboard, in a typical airing cupboard.
Thanks. Now we can take some questions. Ross, would you like to explain your 15 years experience with a ground source heat pump? Because now would be the time to do that.
Well, I always think it's like magic, because I feel like I've got the emperor's new clothes in a weird sort of a way, because you know, winter comes, and in fact, for the first time, as I was saying to you earlier, it didn't work, and I thought, oh dear, that's not good, and that was because I didn't have a way of topping up the loop, and now I've got a top up loop, and now I seem to be back in working order. But in fact, with my system, mine's completely independent of heating hot water. So I actually have an immersion for heating the hot water. So it means it's quite expensive for me, but I think the technology has improved and the systems have improved. So I have got a Kenza heat pump, but it's probably one of the very original ones. Recently asked for the directions, and they had to go to their archives to find the instructions for me. But it has been brilliant, and because we built our house, we had the chance while the diggers were there to bury the pipes in the garden, and we've got underfloor heating, so we didn't have to have a very high temperature for the underfloor heating. So I think the technology has come on a lot, even since we had it put in.
Yeah,
That's a very good point, Rose. If I can add something here, heat pump technology with the supply of heat in the range of maximum something around 50 degrees C work very well with underfloor heating that doesn't need 70 degrees C. That's a very good design for heat distribution and heat generation, heat distribution by underfloor heating and heat generation by heat pump.
Yeah, but sorry, all I was going to mention is if you've got a new build, it's cost effective. But if you're trying to retrofit, it is much more difficult because you can reuse existing radiators. So it's an open question. But there are some things in the chat box. So does somebody want to? Mehdi or John Shaw?
We've got a link from John Booth, who's given us the link to the air source heat pump planning requirements. And they're not terribly onerous. I've had a quick flick through them.
Yeah.
But that's a useful link for anyone. And then Caroline's mentioned, I know of a flat block that has air source heat pumps, and if functioning properly, they do not cause problems for neighbours.
Good.
And Rebecca said also whether you yourself want to listen to the noise whilst chilling in your garden. But the only thing I would say is that unless you are really, really wanting to chill, most of the time you wouldn't be in your garden when the heat pumps would be working hard, or you wouldn't be there for very long, or you'd be working very hard in your garden.
Any other comments? Ross, did you want to say anything else? We sort of interrupted you.
Oh no, I was only going to say the reason I was so interested in this is that, you know, if I move house, I just wondered how easy it was to sort of retrofit, you know, to adapt to using the air source or ground source for somewhere that's got radiators and currently has a gas boiler. That's really why I was so interested to find out how easy that would be for people in real terms. And the thing with our building, we're not a very big building, and we've got quite a lot of glass, and for that reason we had to be very well insulated. So I think that's helped our situation a bit.
Yeah, I think the thing is that this question of sizing of the heat pump is not only a cost one, but it's also physical size inside the building and either noise limit of air source outside the building or the depth of the borehole. So everything suggests the 5 kilowatts is a workable limit because it allows you to install a typical 6 kilowatt heat pump, such as you see below there. It's really the Kenza one is very compact, but there are other makes as well that are very good. So let's move on because there were questions about costs and grant. So here's the cost thing. I'll talk it through and then no doubt there'll be some questions about it. The major difference between the ground source and the air source heat pump clearly is the borehole and the ground loop. So between those two, you have the difference between the ground source and the air source. So it's difficult to generalize, but if you want to figure, air source is likely to be about 60% the cost of a ground source heat pump. But again, the whole thing is size sensitive, and the best advice to do is to restore your radiator efficiency in existing buildings and reduce the heat loss to less than 5 kilowatts. Otherwise, these costs go out of the window. Now, the reason why these numbers are so important is because there is a grant available for converting a gas boiler to a heat pump, either air source or ground source, of about 5,000 pounds, one-off grant for air source, 6,000 for ground source heat pump. So in the case of air source heat pump, you might be talking about having to pay maybe 6,000, somewhere around about that. So the grant will cover about half the cost. In the case of ground source heat pump, the grant will likely cover 1/3 of the cost. So therefore, you have to remember that the air source, cheaper to install, but more costly to operate. Any questions on economics? Okay.
Rayner, we've got a question, but it's not on economics.
Oh, all right. Let's have the question then.
From Rebecca. So does that mean that the sound depends on when and how the pumps are used, i.e. heating, water, central heating use? I misunderstood. I thought that the sound would be consistent all year. I thought my understanding was that it would be kind of relative to how hard it was working, but I defer to Rayner and Mady on that.
Okay, the sound depends on many factors. The sound depends on the design of the blade of the fan in the external unit close to the condenser of the heat pump technology. Depends on whether it works full load or partial load, which means whether for example, it's work for only part of the maximum load of the heat pump system, or it's working full load. For example, if it's a very cold day, the system might work full load, and fan on the condenser depends on the manufacturer. Some of the different manufacturer has different control strategy for frequency control of the fans or not. Depends on the control strategy for external unit, most likely the fan function based on the demand. That means when the demand is high, the fan operate more, and you may hear the louder noise. Again, I just wanted to draw your attention. You know, the noise is a factor. Okay, but we need to know what is something around 40, 45 decibel. We are not talking about a faulty external unit of heat pump. A faulty external unit of everything can be very noisy. A faulty car is very noisy. Faulty laptop is very noisy. Faulty air handling unit is very noisy. Faulty heat pump technology is very noisy. But when the system is maintained regularly, the noise should be in the area of maximum 40 to 50 decibel A. 40 to 50 decibel A means something around when someone which is not very loud is having a conversation with someone else. That means 40 to 45 decibel. It's not an industrial noise. It was not a big bang noise. It's a noise like a conversation. It's not louder than that. I want to give some sense on what is the 40 to 45 decibel. And on top of that, the way that the noise travel, because I'm working on acoustic, I can say something on that. The way that noise travel depends on, for example, if you put the air source heat pump close to the two walls on the floor, we will have different distribution when we put the air source heat pump close to a wall on the ground. You know, the distribution depends on the surrounding area of the heat pump unit. But generally speaking, when we are talking about the level of sound generated in the range of, for the well-maintained unit, something around 40 to 45 decibel. It's the noise like the noise of a normal conversation, not shouting, you know. That's the level of noise that we are talking about. Of course, again, I should emphasize that a faulty unit may cause louder situation and environment, but a well-maintained unit should produce something around 40 to 45 decibel, not more than that. I hope that it helps.
Caroline, you've got a query, please.
Yes. Can you hear me?
Yes.
Thank you very much so far. It's very interesting. We're talking about sort of individual dwellings at the moment, but I mean, close to where I live, we have a new development proposed, and within that, so it's a 250 house development, and the proposal was to make it sustainable by introducing or installing air source heat pumps. And the local electricity provider has said they can only maintain or service 91, I think it was, out of those. So the remaining houses will be installed with efficient gas boilers. And I wonder why are they not being pushed towards a ground source heat pump system that provides for that whole development? What are the economics there that are sort of, or are they, you know, not required to then look for other sustainable sources if they can't actually service all those heat pumps? It feels quite you know, a shame that you know, we're not, you know, the infrastructure is not there to be able to support these sustainable sources.
If I
Wait
can
a second. Wait a second. I'd rather park that question until we finish the slides there. we have the John Sharp and John Booth and Betty and myself have been quite involved in this development you talk about. But I'd rather finish the slides first, and then we can answer your question as best we can. Otherwise, we lose our audience. Yes.
We've got one more question from Rebecca saying, can you repeat the costs, please?
Can I repeat the cost? Well, firstly, ground source is likely to be twice the cost of air source heat pumps. So ground source, air source would be typically 10K, maybe more, maybe less. Ground source typically about 20K. So 10K for air source, 20K for ground source. And these are one-offs, I must point out to you. These are not, these are for individual houses. Grant, 5K, £5,000 for air source, 6,000 for ground source. Now, the most intriguing thing about trying to reduce the cost of ground source heat pumps is the supply of geothermal heat. And I just want to talk you through this because it's something that I've been involved in for many years, trying to get this off the ground. Reading is underlaid by a shallow chalk aquifer which contains sufficient heat to heat all 93,000 well-insulated buildings. So the heat is there. And the reason why it's so good is because the chalk aquifer is fractured. So groundwater flows during the summer to restore the heat supply. So the big question, and the one that I've tried to get some action on, but so far haven't been able to do that, is if there was a utility who could supply geothermal heated water from a communal borehole and install flow and return ground loops along the streets, then the conversion to ground source heat pumps would be no greater than that of air source heat pumps. And remember, they have much lower operating costs. And if an existing utility is not willing to do this, then Reading eventually will have to set up a community energy company which could recover the capital cost of the borehole and the ground loops through a daily standing charge. That's no different to what your gas company or your electricity company does at the moment. So it's an open question as to if and when either an existing utility will take up the challenge, or whether Reading has to develop one or more community energy companies. I'd like to move on just to try and, because there is this is an important slide in terms of the economics of heat pumps. So current price of gas, 10p per kilowatt hour, current price of electricity, 33p per kilowatt hour. So the ratio of electricity to gas is 3.3 today, as of today. Now, the question, therefore, is what is the conversion efficiency of air source and ground source heat pumps? And the conversion efficiency of air source heat pumps is most probably the numbers are given there, 3 to 3.5, but only 2 for hot water. Ground source heat pump, 3.5 to 4, 2.5 for hot water. So the ground source heat pump, as today's energy cost, has a higher initial cost but lower running cost than either air source or gas boilers. I would estimate that the ground source would be £100 at current prices, about £100 cheaper per year than to operate an air source heat pump. But of course, the cost is much greater. Are there any queries over these cost parameters at all? Right, here we are, grants and green mortgages. Only insulation support is the Eco4 scheme, but if you're on low income or benefits, you're not going to be interested in heat pumps. I've already mentioned the boiler upgrade grant, converting heat pumps, heating systems to heat pumps, 5K and 6K. Terms and conditions, consult Energy Savings Trust. Basically, your house needs to be reasonably well insulated. The one that has got the greatest potential, and it is one that is not well known, is that the number of mortgage providers who provide green mortgages has been steadily increasing over the last 10 years. And now there are many of the building societies of banks offering mortgages are also offering green mortgages for warmer homes, and warmer homes also include those fitted with heat pumps with a lower interest rate. So it may be that if you can obtain the boiler upgrade grant and you can seek a green and you can obtain a green mortgage, that you may be able to finance either the air source or also the ground source heat pump through negotiating this with your mortgage provider. So this is something that I would definitely recommend you to invest firstly with your existing mortgage provider. And then if you go on the website, the World Wide Web, and seek green mortgages, you'll be surprised at the number of people offering green mortgages. Any questions on? There's some questions in the chat box, Mehdi or John.
No, I don't think so.
No, that's okay. Then we've got one more slide. Why convert to heat pump? This is the final slide, and then we have to answer Caroline's question. They have a higher efficiency in gas boilers, so low emissions of greenhouse gases. The new homes, government plans to require only low carbon heating systems like heat pumps from 2025, and existing build from 2031 onward. So sooner or later, we're all going to have to convert to heat pump. And Reading has been fortunate by being underlaid by a chalk aquifer, which can supply geothermal heat to all Reading's dwellings. And within the next few years, communal boreholes in Reading supplying geothermal heat are likely to become available. And the only question is, who will take the lead in that? So that's the end of the formal part of the discussion. And now we can try and answer Caroline's. Are there any other queries before we answer Caroline's question?
Rayner, if I can, I would like to highlight 2 points here. Our mission here to provide both advantages and disadvantages of the sustainable solution that we suggest here. One thing that I would like to highlight specifically is that if with the current energy market, someone spent X amount of £1,000 for switching from gas boiler to air source or ground source heat pump. With the current energy market, there shouldn't be an expectation to reduce the running cost or energy bill. That was the point that I wanted to make it crystal clear. It's a sustainable technology, heat pump technology, but if you invest on it, it doesn't necessarily in the current market. We don't know what would be the situation of the energy market in the future. With the current market, there would not be any positive impact in terms of reducing the running cost of the heating system. That was one point that I just wanted to highlight. Another point was about the green mortgage. As Rayner mentioned, green mortgage are available at the moment. as recent as last night, I had a look at the green mortgage. Provider X had the mortgage of something around 6% interest rate for the normal mortgage, but 5.5 for the green mortgage. But it doesn't necessarily mean that the green mortgage is the cheaper mortgage in the market, because it's a free market. You may be able to find the cheaper mortgage from another lender. But I agree that the green mortgage is the lender provide mortgage with the lower interest rate for building with certain criteria compared to the normal rate. But again, the rate of green mortgage from provider X might be slightly higher than the normal mortgage of provider Y. These two I wanted to highlight it here.
All I'm suggesting with green mortgages is you go to your existing mortgage supplier and you say, look, I'm thinking of installing a heat pump, and it will therefore enhance the value of the building and also ensure that the building is well insulated and is well heated. Are you prepared to offer a green mortgage? And if they say yes, then the answer is, for the sake of one email or one letter, that's fine. If they say no, then the answer is do look on the web, because I think the majority of mortgage providers are now are realizing this because of this timetable. Something's got to be done. We already have lots of problems with just paying existing energy bills. So where could the money come from this conversion? But over the next 20 years, we're all going to have to convert to heat pumps. So this is something that mortgage lenders have to think about and decide what it is that they want to do. I think we should come back and answer Caroline's question. And I'd just like to kick off with a comment, and then maybe John Sharp or one of the others, John Booth, can enlighten us. The issue about the Caversham Golf Club development, which is the one that you're talking about, is related to the supply of the DNO, Distributor Network Operator. So that's the person who supplies the electricity or transforms the electricity from the grid down to a voltage that we can use at the home. The DNO is SSEN, Scottish and Southern Energy Networks, and they were not willing to increase the supply to Caversham Golf Club. In other words, they said, this is what our existing supplier is willing and supply. We're not willing to do this. But, and this is the question that you need to understand, Caroline, and that is, it's only a short-term solution. In the long term, SSEN has got to face the fact that all 93,000 houses in Reading are likely to switch to heat pumps. So by delaying investment now, they're going to have to make a much higher investment later on in order to provide the supply that's necessary. It isn't as if it's nice to have. That's the government requirements, and either SSEN is willing to increase the supply, the low voltage supply, or they'll have their license taken away. It's as simple as all that. So the long-term future is clear, and all that SSEN have got to decide is jam today or jam tomorrow. So that's my viewpoint, and I have discussed this with them. So I have tried to influence them at a level where they might be interested, simply because of the conversion of all 93,000 houses in Reading. John Sharp or John Booth, do you want to please add to what you've done?
I'm very happy to let John Sharp go first, and
shall I start from the beginning, because the the first point is why are they using air source heat pumps instead of ground source heat pumps, bearing in mind it's a new build and it's on the same chalk aquifer. And moreover, there's a sustainable design and construction policy which the Reading Council has, which states, in general, ground source heat pumps should be investigated as a priority over air source heat pumps. This is because they enable greater seasonal efficiencies. And then it goes on to say, evidence should be provided at the detailed planning application stage where ground source heat pump systems are discounted and an air source heat pump system selected with the following technical analysis. Well, what happened in the case of the Caversham Golf Course is that they tried to rule out the use of ground source heat pumps at the outline planning stage, and therefore by doing that they were able to, if they achieved it, and they did, they would add to the value of the property, which they then sold on to the developers, having got the outline planning permission. The reason that they gave for it being not practical, and I looked at the consultant and the person that had written it, who is a recent graduate who wrote this paper, was that they said that the Environment Agency wouldn't allow them to use ground source heat pumps for the risk of the ground source being polluted, which just seems to indicate to me that they really had no understanding of how the system works. But that didn't matter, because if they could equally assume that the planners and the council planning committee were equally inadequate in their knowledge of the system. So despite me writing to each of the members of the planning committee individually, explaining to them that this was a bogus reason for ruling out ground source heat pumps, and of course they would have used less electricity, of course, so they could have done more without this supply obligation. They still allowed it to go through. They then sold that land onto the group who are now developing it, who have then gone on to put in a planning application, which they tried to change it from air source heat pump to a subset of air source heat pumps. Again, with this, I now saying that it's down to the lack of supply. In all the planning documents that I've seen, I've never seen any evidence from the environment agencies that, one, they would have refused the planning application because of their concerned about the groundwater being polluted, and two, I haven't actually seen anything from the suppliers saying that they're unable to supply more electricity than to. They may have done, it's just not in the planning system as a piece of public information. However, this may be possibly as a result of our continuous pressure on the council to try and enforce the policies. It's great they've adopted these policies, but if they are continuously ignored by the developers, which seems to be the case, it's pretty pointless having these policies. However, what they have done is that when they put in the request to change the planning application so that it reduced it to a much smaller subset of about a third of the planned development, the council has put in a clause that says that planning permission is subject to the conditions as recommended, blah, 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 blah. But it goes on to say that that if you're going to develop any phase of the development that includes proposed developments dwellings without an air source heat pump, a review of the energy capacity supply for the development be submitted to the planning authority for review to establish whether an air source heat pump could be incorporated into the development at that stage. And that is where it was demonstrated that there was not capacity, details of the future proofing of the dwellings for installation of an air source heat pump to be submitted for approval. So there's a small glimmer of hope, at least from this clause that they've inserted as a planning condition, which means that because often this planning, they haven't got to the detailed planning stage yet. They're likely to release the houses in phases and develop it in phases as they are predicted in this planning clause condition, and the situation may change as time goes on, and at each phase, when they come to apply for a detailed planning permission, they have to justify why it is not possible for them to use air source heat pumps. It's no good saying they haven't got the supply now. They're not building the houses now, but at some point in the future, when they come to doing it, then they will have to justify it. I think that's my very quick summary of the situation. Hopefully that was helpful.
John Booth, would you like to add to that?
A little bit, maybe. It is complicated. I think the developers don't want to have to invest. You have to invest more heavily if you're going to put in ground source and air source. Air source, you just put in to each house a supply of electricity, and that's all you do. And then the air source heat pump exterior unit sits on the wall and makes a noise to your neighbours. And that's all as a developer you have to do, and you can develop your site sort of bit by bit as you go. If you're going ground source, it would reduce the total electricity demand probably, but the installation costs would be much higher, particularly if you do the system that certainly I think Rayner and I and John would like to see, which is to run ground source loops shared between a number of houses, so that if, say, one of the boreholes gets blocked, you can switch, you're sharing several boreholes between several houses, but you then have to put in a marketing and vending system as well. It becomes more complicated, whereas if you just have air source, it costs you less to build it, you can build it quicker, and there's no complexity in arrangements. So I can see the attraction to a would-be developer that you would do it quickly, but in terms of reducing electricity demand and electricity consumption, it's the wrong way to go. There is also this issue about the supply conditions. Electrification is being pushed, both electric vehicles and electric heat pumps, and that is going to, I think, raise peak demand for electricity around the place. There are various techniques of storage that Rayner knows more about than I do, but a lot of places, the electricity systems are not really said to be able to cope. I actually live in Wokingham, and over there, Wokingham had plans for solar farms, which have had to be put back because apparently they can't be connected till I think it's 2037 or something silly like that, is what the electricity supply and connection companies are saying. So this, I think, is a very big issue around the country, not just in Caversham. But yeah, it's all difficult. Thank you.
Let me just summarize. There are costs associated with installing the heat pumps, both in terms of the heat loss of the homes and the actual costs for the heat pumps or air source heat pump. It's clear that air source is cheaper than ground source as far as the developer is concerned. As far as the DNO is concerned, the situation is reversed. The ground source heat pump is much better than the air source heat pump. So consider a situation like last winter when the air temperature reached -10. At -10, your air source heat pump will not be able to heat your home, and therefore you'll have to use auxiliary heating, which normally is direct heating. And so you would end up with having a problem of supply in Reading which they cannot meet. So therefore, the question that you need to ask, and which has not yet been resolved, but we need to do this on in some form of development or another, is to try and reduce the global cost. That's both the cost of installing the heat pump, reducing the heat loss, and the supply cost of the low voltage too. And what we need to do is to optimize this in such a way that the total cost, the global cost, is reduced, so each of the partners benefit from doing this. And that's why setting up communal energy companies with supplying geothermal heat is clearly the long-term solution for somewhere like Reading. And whether the DNO will invest in this or not, I don't know. Caroline, you've got a long answer to your question. I don't know whether that helps you or not.
Rayner,
Yeah.
if there is any chance for me to add to take it to another extent, I would like to add one quick things to the question that Caroline asked and we didn't answer, why they didn't move to ground source heat pump system, even though if it might be a slightly different from the view that Rayner and John has here. Even if the developer moved to the ground source heat pump, they were able to supply the energy to, instead of 90 air source heat pump dwelling, they probably would be able to supply energy for 120 ground source dwelling, not more than that. And the problem of the lack of supply was still there, regardless whether it's air source or ground source. There are lots of research and development in that area to provide demand response. And the main challenge, I can to some extent understand the limitation of the energy suppliers. They are committed to reduce the peak demand, because the peak demand 3 to 4 times sometimes the off-peak energy demand. They want to reduce the peak demand that dictate how much they can supply. And the heat pump technology, generally speaking, they are operating on the maximum capacity during the peak hours, and this is their problem. In terms of communal energy center or energy hub, again, I'm very much a fan of that kind of initiative, but at the same time, we should appreciate that there is no legislation to the extent of charge that at the moment those community hub should and could charge the individual for delivering the heat. There are all around the UK, there are community hubs that charging unreasonably, and at the moment it's not regulated. It's another dimension to a challenge that we have. In short, demand response will come in the next coming year to address this, and hopefully there would be a regulation on the energy hub and district heating soon in the UK, but unfortunately it's not yet available and in place for supporting those initiatives.
I would just add something else, Caroline. Some 30 years ago, I worked with Scottish and Southern Energy in the north of Scotland to introduce ground source heat pumps to the north of Scotland in place of electric storage heaters. And we got permission from Ofgem to install, not only to install them in 100 houses, but to offer a heat pump tariff, which was substantially less than current electricity charges, 1/3 less than the current charge. And the quid pro quo, or the advantage of this, was that one used these houses, the heat capacity of these houses. So during times of peak demand, up to 4 hours a day, but never 4 hours at one time, the supply company, the DNO, could switch the supply to the heat pumps off. So in this way, they could balance the demands. The result of this was that the 100 houses were snapped up very rapidly with ground source heat pumps. Even in very cold weather, they were able to have sufficient heat capacity to do it. So there are options available that have been tried many years ago. And of course, you should remember that there are somewhere between 15 and 20 million heat pumps operating in Europe, and the DNOs have got used to doing it. So it isn't if we have to invent everything here in the UK. We've tried and proven to the north of Scotland, and there are other solutions available. What we really need to do is to identify a developer in Reading or a social housing provider or Reading Borough Council who are willing to go along with a managed scheme where we answer all the outstanding questions, put them into the public domain so that other developers can benefit from what, how, and who to do that. Caroline, you've had a very long answer to a very short question. Any other comments you like to make?
Thank you very much for that. I mean, it does really beg the question about where are the policy developments in this area? Why aren't developers being forced to take a more sustainable route? Even if the cost sits with the developer. I mean, we're being asked to take on the cost of putting in ground source heat pumps or air source heat pumps, but actually when new developments